I've temporarily removed the case from the table here, and I want to pre-assemble some of the components before we actually do the final assembly. Now let me start with the direct clutch. I'll put the number 7 thrust washer or Torrington bearing in place. Remember, this is the two-part bearing. It has this little washer or shim that goes on first, and we put the bearing on, and that little raised inner lip that needs to be facing up. Drop that right down on there, and maybe take a little bit of transmission fluid, kind of squirt on it. Then we want to put this hub in place. Now there's a couple hubs that look similar, but the one we want to use here is the one that has the large diameter hole here. And you just have to work it back and forth until all of those clutch fibers engage. Just work it back and forth. Okay, we're in. You can tell that you're in when the hub is actually resting on the bearing there. Now let me hold this, turn it upside down, and I want to put the number 8 thrust washer here. Put a little bit of Vaseline here. Take the number 8 thrust washer with that little raised inner lip facing up along with that open face area where you can see the rollers. It's facing up just like that. And then I want to install this onto the output shaft. Squirt a little bit of transmission fluid on the bearing and then slide it right onto the output shaft, just like that. Now I want to take this ring gear and install it. Go right over top of this, get it engaged in these lugs in the back, and then put the snap ring in place. Be sure that the snap ring is all the way fully seated in its groove. On this side, make sure your hub didn't fall out. If it did, you should be able to re-index it, no problem. We'll put this aside. Now I want to take the first gear one-way clutch and assemble it in the planetary along with the center support. Remember, the number 6 thrust washer is already down in the planet. Make sure that it's oriented right. That's the bottom side right there. This is the top side, the kind of area where it's somewhat has an open face. You'll see that you really can't put it in upside down. It won't line up with the ramps that are on the planet. Alright, and you just have to kind of work it down in there. Sometimes one of the rollers will get caught and you'll have to make sure that it's all the way down in there, like that. Then we take the center support. Might want to squirt a little bit of fluid on it. And we lay this on top of there. And you have to start turning it counterclockwise to get it to engage. Just keep turning it counterclockwise, and it'll fall into place. And again, turns counterclockwise, locks clockwise. If it rotates in both directions, there's something wrong. There's some springs out of place, something like that. Okay, we'll put that aside. On the table now, I have the reverse clutch drum, the clutch hub that has the smaller hole in it, the forward clutch drum, the sun gear shell, and the forward sun gear. I've brought my 4x4 blocks of wood back onto the table here, and I'm going to take the reverse clutch drum and place it right on the 4x4s. I'll take the number 2 thrust washer, which is a Torrington bearing on this one. Again, early model ones will have a Babbitt type thrust washer. It's a large diameter one, has that little inner lip, and that inner lip will go down into the drum. Might put a little bit of Vaseline on it. Set it right down in there. Now I want to take the forward clutch and place it down into the reverse clutch drum. Just like this. Keep spinning it around until it fully indexes. That should be it right there. Now I'll take the number 3 thrust washer and hub and place it into the forward clutch. I'll put some Vaseline down in this cavity on this hub. And on this bearing, you want the outer race, the lip part of the outer race facing up like this. If you mounted this one upside down, you'll see that it just doesn't fit right at all. So you want that outer lip facing up on this hub, just like this. And then we'll set it right down into the forward clutch fibers and keep rotating it around until it goes all the way in. That should be it. Again, you could look right down in there and you can see that the hub is laying directly on the Torrington bearing. Next, we'll take the number 4 thrust washer and we'll place that so this inner lip is facing up. Again, if you mounted this one upside down, you would see it really wouldn't fit at all. So inner lip facing up, just like that. And then we take the Sun Gear shell and put it right down on top of it. I might squirt just a little bit of fluid on it. Now sometimes this thrust washer will want to fall out of place and you may have to kind of re-index it. Just send it on down through there. You can kind of feel in there and you can make sure that it did index properly. And you'll know you're all the way in by looking at the lug area here. You can see that the shell is down below the lug area a little ways. If it's setting up, you know, like this, then one of those thrust washers is out of place or you didn't get the hub all the way down in the clutch fibers. This one looks okay. I'll reach underneath here, hold it all together as a single piece, flip it around, and set it off to the side on the bench. All right, the case is on the table. Let's start putting this thing together. We'll take the number 9 thrust washer and put that down in the back of the case. Take a little bit of Vaseline, put on the inside of that race where that raised lip is. Turn it around, open face the side of the bearing facing us, and we'll put it down on that ledge in the back of the case. You may have to kind of push it in, but there's a slight interference to that lip, just like that. And we'll squirt a little bit of fluid on it. And make sure I got plenty of transmission fluid on that bushing in there and on the back side of the case in this area. And I'll take my block of wood, stick underneath the case right here. Now I'm going to take the output shaft assembly and go right on down through there very carefully. I've made sure that there was plenty of fluid on the output shaft too. Alright, and there you go, it's in place. Now I'll put the governor on, and what I need to do is rotate this shaft so the little indent where that ball check goes is facing the top, like that. And I'll take the little ball check and drop it right down in that little indent. Then I'll take the governor and the counterweight and orient it like you see here with this open slot area that will face the back of the transmission. And the slot that's in the counterweight here will go over top of that ball check. And you may have to wiggle it just a little bit to get it to go past that ball. There you go. Every now and then you may have to use like a plastic hammer and kind of tap on it. And now that the snap ring groove is revealed, we'll take the snap ring, slide it on there, and install that. And be sure it's all the way in the groove. Now I'll take the extension housing gasket, I put a little bit of Vaseline on it to kind of glue it in place and stick it right on the back of the case here. Then I'll take the extension housing and put it on. I need to put the seal in place. I usually put a little bit of Vaseline on the inside of the seal that holds that garter spring in place, keeps it from popping out when you pound the seal in. Now the bushing that was in this extension housing was in good shape. If you do have to replace the bushing, just remember there's a little hole, a little slot in it. and that slot will face down in a little cavity here in the extension housing if you have to replace it. All right, let me take the seal and I'll tap that into place. Slide the extension housing over the output shaft, index it to the case, and put your bolts in. Go ahead and tighten these down. If you have a torque wrench, it's about 20 foot-pounds. Okay. And obviously, if you had a four-wheel drive, your output shaft would be shorter, and of course the extension housing would be made different with the open back face, which bolts to the transfer case. All right, let me take my block of wood out. Now from the front of the case, I want to take that snap ring and lay it down on that ledge back here near that ring gear. There you go. Now it's not absolutely necessary to have that snap ring back there, but it does help hold that reverse low band in position. I'll take the low reverse band and install it, and notice the orientation. These two lugs will intersect those two anchors that's in the case there. And we'll just run it on back down in there. Okay, see how it hits the anchors there? And that snap ring that I installed holds the band in there nice and square. Next, we'll put the planetary in, the assembly. These splines here will engage those splines that's down in that hub. Of course, these teeth will go into the ring gear, and the center support will tie into the case. What we want to do is this open slot here, we want to orient that to that little lug right there. And as we go in with this, we'll have to turn the planetary clockwise a little bit to get it to engage. And I have to go a little bit more. I'm not all the way in. And now I think I'm in. Until that snap ring groove right there is revealed, you're not all the way in. It looks like we're okay. Now we have to install this little anti-clunk spring down in that cavity right there. Alright, this is the orientation in which it installs, just like that. Go down here, use your thumb. Might need a screwdriver to help you along just a little bit. Now I'll take a punch and use the butt end of the punch. Go down in there and kind of tap in the two ends of that spring so the ends of that spring is flush where the snap ring groove is. Alright, see the little spring tips right there? And that's where the spring will ride right against that. If this falls out of place, it rotates on you, pull it back out and try it again. You may have to do it a couple times. Now I'll take that other big snap ring that's got the little ears on it and send that down into the case, and I want one of the ears to line up in this area here near where the other anchor is, and the other ear will be right in this area here. Alright, now we'll take the forward sun gear and put it down into the planetary where it will rest on that number 6 thrust washer that's in there. And on the front of the sun gear, I want to put the number 5 thrust washer. Remember, it has a little inner lip that faces out, and this thrust washer is the same as the one that's inside that sun gear shell. Alright, we'll just put it right on down in there. I have to turn it a little bit to index it. There you go, just like that. Now we want to put the input shaft in, that long skinny input shaft, and since I was going to use that little circlip on there to keep it from going too deep into the direct clutch, we'll put that in first, that side first, right on down in there, just like that. Alright, now for the most challenging part of this installation. We want to take this clutch and sun gear shell assembly, slide it down onto that input shaft, get it to engage those teeth and the planetary gears. The problem is as you're sliding it down, the sun gear shell will want to fall off. So what I do is I use this little hook tool, come in, kind of hold the back of the sun gear and slide that in there, and as I get deep enough I take the little hook, slide it out, and hopefully everything will engage correctly. Don't be surprised if you'll have to do this 2 or 3 times. There is a bit of a challenge to do this. Okay, I think I've got it. Usually you can tell you're in deep enough because all the splines will be revealed on this smaller input shaft. At this point we need to set the transmission up vertically. Now to do that, if you had one of those 17-gallon drums, it's just the right size, it would go right on up to the bell housing. What I'm going to do is I'm going to take that PVC pipe that I cut out, put that right on the output shaft, just like this, and then mount this on the floor. The main thing is you don't want the output shaft to touch the floor. If it does, it will slide up and it will interfere with your end play check. Okay, let's get this thing on the floor. All the splines are exposed on the inner input shaft, and the lugs of the reverse clutch is all the way down in the sun gear shell, and that tells me that everything is pretty much in position. Now we want to do is to take the overdrive band, and I am using the 1.5 inch band since I'm using the original drum, and we want to take, and this area of the band will have to intersect in that lug that's in the case right there. And so all we do is just lay it right down in there and get it to engage that lug or that anchor that's in the case, and let go of that. Now we want to check the end play, and to do that we're going to measure up from the surface right here, which faces the select fit thrust washer that's on the pump, and we want to measure up to the surface of the pump flange area right here. To do that, we'll use this special Ford tool here, and it's a straight edge and it has a thickness of 700 thousandths of an inch. Now the chart that's in the Ford book is set for this thickness of gauge. If you had a different gauge thickness, you could adjust your measurements accordingly. Now what we can do, we can take a depth gauge to go down through this hole, or what I'm going to do is just simply use a vernier caliper and go right on down to through this hole and hit the top of that thrust area right there. And I'll just set that right on through there, and I'll take a reading, and I've got, looks like about 1.525 thousandths of an inch, or 1.525. And you should check it in a couple places, you know, about 180 degrees away from each other. And I'll set it down through there again. Take another reading, and it looks like, let's see, 1.530. So it's between 1 and 525 thousandths and 1 and 530 thousandths of an inch. Now we'll go over to the chart. And the chart here says that if you're between 1.518 and 1.534. Use the number 3 thrust washer, which is the natural colored thrust washer, and that's actually what came out of the transmission right here. Next, I want to put the intermediate clutch pack in. I'll do that by putting the pressure plate in. Now this pressure plate is made for a 3-fiber clutch, which is what this had. If I wanted to change this to a 4-fiber for all-out high performance, or if it happened to be a 4-plate to begin with, what you would have is a thinner pressure plate. You would have this one right here. As you can see, it's a little bit thinner. And of course, by being thinner, it gives you more room to put an extra fiber in. I'm going to stick with the 3-plate on this one. Take the smooth side up. You orient the lug pattern so it lines up with the lug pattern that's down in the case. It's just like that. And then you start alternating. You could put a fiber on next, down over top of that inner race, and then a steel, and another fiber, and another steel, fiber, this is the last fiber, and then the last steel. And just like with setting the end play, we take that measurement bar, lay it down in there, and we'll take our caliper and go down through the hole here and take a reading, and it looks like it's 1.630. and I'll take a reading off the other side, kind of take the average, and that one is 1.635. all right, the Ford spec says that it should be between 1.634 and 1.646. Now, with one of the readings giving me a 0.630, that puts it a little bit to the tight side, a little bit out of spec, but it is so close that I think on this particular transmission there's enough wiggle room there that it would be fine. If your spec was way off and you needed to make an adjustment, these steels can be bought with different thicknesses. Now, your overhaul kit will probably only have a single set of steels, and they'll all be the same thickness. But you can get different thickness steels, and you can mix and match the different sizes to get the reading that you need. I think on this one it'll be fine. Now we can take the pump gasket, lay it right down in there, make sure all the holes line up. If they don't line up, maybe flip it over, make sure you have the right side facing up. If you have a metric bolt that's the right size, you could cut the head off of it and make a little alignment pin and stick down in one of the holes. And I've taken some Vaseline and go all the way around this opening where the pump goes down, makes that O-ring on the pump slide in a little bit easier. And I put the correct select fit thrust washer on the pump and put some Vaseline on that to kind of glue it down. And now, of course, we need to line up, you know, these holes right here have to line up with the holes that's in the pump. And I'll flip it upside down, send it on down through there very carefully, over top of that dowel pin that I made. Now, if you didn't have that dowel pin, you could take something like a Phillips screwdriver and kind of go down through the holes and kind of wiggle the pump around a little bit to get it registered. And put your bolts in place, finger tight for now. Now I'll take a speeder wrench with a 10mm socket on it, and I will very slowly go back and forth and just bring these bolts down carefully. If I don't stagger my threading down of these bolts, it could possibly interfere with one of those slip rings that's on the pump and cause it to snap loose or break. So I want to be very careful, back and forth until it bottoms out. Looks like it's going down real nice and even. And it looks like it's tight all the way around with the speeder wrench now. Now I'll give it a final torque of 20 foot-pounds. Okay, and now you always want to make sure that both input shafts turn. That lets you know that nothing fell out of place. Look okay. Now we need to put the transmission back on the table. We're on the downhill slide of putting this transmission together. A couple servos, valve body will pretty much be done. What I want to do now is to put the low reverse servo piston in, and they come in different lengths, and I want to show you how you identify the length of the piston. You take the servo piston and you look at the bottom of the stem, and you look to see if there's a ring there. This one happens to have one ring. You may find no ring at all, or 1, 2, or 3 rings. The more rings that you have, the longer the stem. This was a 1-ring piston, so we will replace it with a 1-ring piston. I do have one with 3 rings just to show you what it would look like. Here's a 3-ring one right here. To install the servo, you want to look down in the hole, make sure that the band is in position. You might take a screwdriver, push down in there, make sure it's right in place, so when the pin goes in there it will engage the band. Put the spring in place, take your servo piston, slide it right on down in there. Take your cover, and I do have a new cover, and this is the bottom side, this is the top side. It actually says outside right on it for the correct orientation. And make sure you have some transmission fluid or some Vaseline on all these lips here, so make it a little bit easier to install. And push it down, use your thumb pressure, and you will have to push it pretty hard, enough to reveal that snap ring groove and install the snap ring. Alright, but what if you're not sure if you have the right length servo? Well, there's a fairly easy way to verify it, and there's a lot of leeway here. The travel of the piston can be anywhere from 125 thousandths to 1/4 of an inch, so there's plenty of leeway. But just to be on the safe side, we can verify if it's the right length. I took an old cover and cut it in half. Actually, I didn't, not quite in half, maybe took 40% of it off. And I can use this to help me measure it. I'll put this down in the hole, take the snap ring, get it down low enough that I can put the snap ring in its groove. There we go. No, not quite in. There we go. And I can take the piston and make sure it moves, so I know I have some travel. And since we know the minimum spec is 125 thousandths, well, that's 1/8 of an inch, and I have a little short 1/8 inch drill bit here. And I'll just simply press the piston down with my thumb, and it's going to take right much to do it because that spring is real strong. Push it down as hard as I can, and then slide the drill bit under it, and it easily goes under there, so I know I'm within the minimum spec. And if I was worried about it having too much travel, if I had a 1/4 inch drill bit that's been cut off, I could try sliding that under, and if it didn't go in, then I know I'm in the ballpark, and it shouldn't be any problem at all. It looks like this one's going to be fine, so I'll put it back together. Okay, in. Now I want to install the overdrive servo piston, and the band will have to be lined up. Most likely it will not be directly under the hole. To get it under the hole, Let me tilt the transmission over here so you can see the other side of the case. And back here where the band is, you want to take a screwdriver and you kind of fish the band over in that direction. And then you can take another screwdriver and go down the hole, and you'll be able to tell that you've got a hold of the lug on that band. Once you get it positioned with that screwdriver, push it down kind of hard, take this screwdriver and kind of jam it down in there. That'll keep the band from springing back. Okay, I can remove that screwdriver. I'll bring the case back up. I can look down in the hole and I can see that the band is in position. I can check one more time with the screwdriver, no problem at all. Okay. I'll take the spring that goes down in there, made sure there's plenty of transmission fluid in the bore. I've put 2 new rings on the cover, they're square cut. Put a new O-ring on the piston, and this was a B piston. This is the middle size. You can have a C that's even smaller, that's on 6-cylinder cars. B is on most of the 8-cylinder cars. And then specialty cars like the Thunderbird Super Coupe, and there were some trucks that had the A piston. And that's even larger, and that's the one you really kind of want to use in a high performance application. All right, and I'll just set that right down in there. Flip it upside down. Put it down in the hole, and I need to press pretty hard to get it to reveal that snap ring groove. Now those O-rings are so tight that I may need a little help. I'll take this little plastic hammer, kind of tap it down. Okay, take the snap ring. This is the smaller of the 2 snap rings. The low reverse has a slightly larger snap ring. Put it in the groove, kind of keep my little thumb pressure on it. And take my screwdriver to help me get it down. And there you go. It's in. You can look back in the back, make sure that the band did get located. You can see that it did catch. Servo pistons are in place. Normally at this part of the video I would be doing an air check. Now doing an air check on AOD transmission is a bit of a challenge. It's hard to get your air nozzle down inside these passages. That's why Ford came out with this plate. You put a gasket on, you lay this plate down, take some special short screws and bolt it all down. You have these holes are labeled, send air down through it, does a good job. Most likely you don't have this plate. And by the way, we did air check the clutches on the on the pump and on the output shaft, so we're pretty confident that we're in good shape as far as the pistons go. I did find that there's 3 passages you can get to with the air nozzle, so we'll do those air checks anyway. In the back of the transmission we have those 3 holes. Remember, this larger hole has that governor screen in it. That hole goes to the direct clutch, and this other hole is the pressure coming from the governor. So we can take the air blower and stick down into that middle hole and check the direct clutch. Now listen. Hear the thud? Okay, so we know that's all right. Now let's go to the front of the transmission. On this side you can see where I've made a little mark on this passage here. That's the intermediate clutch passage. Next to it is the forward clutch. It's actually this long channel right here. And then this kind of funny shaped area here is the reverse clutch. All right, I've already checked in the reverse clutch. You really can't get your blower in there to really check that. The forward clutch, if you angle your blower just right, you'll have a bit of an air leak, but you should be able to engage the forward clutch. Let's give it a try here. Hear it? Hear that piston going in? Right, much air leak, but at least we know that the piston is moving. Now for the intermediate, I need to make a couple things. I'll take a vacuum hose and stick on my blower. Then I take a slightly larger hose on the end of that, and that should cover up pretty much that whole cavity. Let's see if we can make the intermediate come on. Okay, hear that the piston going in? A little bit of air leak, but you can definitely hear the piston go in. We can put the valve body on now. I like to take a little bit of transmission fluid and just kind of squirt on the bottom of the case here. Then put the gasket on. There should only be one of these gaskets in the case. It has the 3 great big holes here. And the little bit of transmission fluid will kind of keep the gasket from moving around. Then we take the valve body, lay it on, and what we have to do is we have to put the TV linkage in this area right here, and of course the manual valve has to engage the manual valve linkage here. The linkages are lined up now. Now we want to line up the valve body with the case. So we take those 2 shoulder bolts, if your AOD was equipped with them, and we put one in this hole right here. You kind of wiggle it around, make sure your gasket is in position, and put the other one in this hole right here. Those holes are slightly smaller, and that helps line the valve body up with the case. Okay, there should be 6 more short bolts. 3 of them go right here on this side of the valve body. 2 of them go on this side right here. And the last one goes right here inside this little circle, that hole right there. Now the longer bolts will go in all of the rest of the holes in the valve body. Now get all these bolts down finger tight or just snug with a little wrench. And the last one I want to put in is this hole here, and this holds the little spring detent. Now there is an up and a down to this. Do not mount it this way with the, let's say, the sheet metal part facing down. It could lodge up in one of these little rooster cones here. So it must be like this, where the sheet metal is on the top, curls around like this. That'll keep that little sheet metal piece away from the rooster cone. All right, we'll put the last screw down in there, kind of compress it a little bit, and tighten this one down. Now these bolts need to be torqued down. The spec on these bolts is 80 to 100 inch-pounds. So if you have an inch-pound torque wrench, put your 8mm socket on there and torque them down and make sure that you hit every one of them. I would go to the low end. I would go to the 80 inch-pound end. It's very easy to distort this valve body. You're less likely to have a problem if you're on the low end of the torque. If you over torque it, it can distort the valve body, stick a valve. That's much more of a problem. Now if you don't have an inch-pound torque wrench, you can get away with using a speeder wrench and put your 8mm socket on there and just use one hand. And when you turn it, just use one hand like that and go all around like that. I believe if you use one hand, it's very difficult to put a lot of pressure on it, and it should keep you from over torquing the bolts. If you have an inch-pound torque wrench, absolutely use that, and I would go to the 80 inch-pound end of the spec. Okay. Now we want to take that little counterweight spring that's mounted on the TV linkage and put it in that little V slot that's in the separator plate. So I'll bring it on around, put it right there. Now we'll put the filter on. I put a little bit of Vaseline down in this little grommet here, and put a little bit of Vaseline here to glue this little cork gasket in place. Place it right over the holes. You have 3 holes, one here, and one here. And there'll be 3 real short screws. Go in those holes and screw those down. You can run those down about 80 inch-pounds. And of course, if you had a 4x4, you would have a filter that would look a little different. You'd have a little extension right here, so it reaches down into that little dropped area that's on the oil pan. All right, and then we'll put the pan gasket in place and line it up. Then take the pan, and I always like to put a little magnet in the corner here. You can get a magnet like that from Radio Shack or a hobby store. I like to put it on this side because it doesn't interfere with anything in this area of the transmission. Place it right on there and run all your pan bolts in. Now just use a speeder wrench on these bolts, but you can torque them if you want to. I think the spec is 12 to 16 foot-pounds. All right, let me flip it over. We'll put the neutral switch in, make sure there's a good O-ring on there. Tighten this up with an end wrench, or if you have a thin wall 3/4 inch socket, that'll work too. Okay, move it around to this side. Put your dipstick tube in. Absolutely put a new O-ring on the dipstick tube. If you don't put a new O-ring on it, I will guarantee you it will leak. So slide that down into position. All right. Around the front of the transmission here, I have the torque converter. I used this end play tool, and I verified that the end play was 25 thousandths of an inch, which is well within the specs. But as I said earlier in the video, if there's any question about the torque converter, replace it. If you don't have a converter that you have a good history on, it's the safe thing to do is to replace it. Now, several things have to line up when I put this in. The stator support, of course, has to line up with the stator inside the converter. The 2 input shafts have to line up with the splines that are on the inside. And the 2 lugs that are on the converter hub have to line up with that inner gear of the pump. All right, I'll just stick it right on in. And as I go in, I'll have to kind of rotate it to get things to line up. And I got one thing in, and I believe I'm all the way in. You know you're all the way in when you can look down the straight edge of the bell housing and you don't see any of the hub sticking out beyond that. So we'll go right across the bell housing here with a yardstick and put it right in front of that hub, and I can look down in there and I can see, oh, maybe 1/8 of an inch that the hub is in deeper than this straight edge. So I know I'm in all the way. Before we leave the AOD transmission, I want to go over the procedure on adjusting the TV linkage, or the throttle pressure adjustment. Now, over the years, there's been a lot of misconceptions on how you make this adjustment. Many people wind up overcomplicating it. It's actually quite simple. I've got a couple mock-ups here that we'll use to illustrate how to do it. I have an upper plenum to a 5-liter Mustang here. I have it upside down because on a Crown Vic and a Mustang and a Thunderbird that uses a 5-liter engine, The adjustment cable is on the bottom of the throttle body, which would be difficult to see. So for illustration purposes, I have the intake upside down so we can view it a little bit easier. I also have an upper plenum to a 5-liter truck motor, and I have the cable assembly on it. Now, to make the adjustment, when it was done on the assembly line in the late 80s, early 90s, all they really did is what I'm going to do right now. Okay, as you can see the cable, I have it loose. It's not hooked to the throttle body. There's a little plastic tab here. It's in the up position, and that allows this adjustment piece to easily move back and forth on the little sleeve here. Now if we look over on the transmission, as you can see, the cable is all mounted to the transmission. The bracket is bolted to the bell housing area. The cable is hooked in a little ball socket that's on the end of the linkage here, and there's a spring in here which is putting the linkage in the idle or low pressure position. You can see it's spring loaded back. Okay, let's go back to the throttle body. On the assembly line, they would just simply take this loose end of the cable and line this ball socket up with the bushing that's in the throttle body, just like this. Index it over the hole and then snap it down. And when they did that, that little plastic piece would come up into the ball socket area here and lock this sleeve in place. In that position, now the cable is basically neutral. It doesn't have slack on it and it doesn't have tension. And really, that is all the adjustment that was made on tens of thousands of cars going down the assembly line. Let's take a look at the truck intake and see how the cable adjustment is made on that. The cable adjustment on the truck is made very much the same way as it is on a car. The one difference is the adjustable sleeve is back here on the bracket and not on the pivot point. So what you do is you take this little lock tab and pull it up. That allows the sleeve to move back and forth, and what we want to do is just bring that sleeve back till all of the slack is out of the cable. And just before you actually get tension on the pivot point here, then that's the neutral position. We don't have any slack and we don't have any tension. Take the lock tab, push it down into the sleeve, locks the sleeve in place, and 9 out of 10 times that's all the adjustment you need to make. Okay, you've probably read in a repair manual or read online that you can make this TV pressure adjustment using a gauge and a special tool, and we'll talk about that now. You need a gauge that's accurate at a low pressure reading between say 0 and 50 pounds. It needs to be good and accurate. Take your hose and you hook it to the TV tap on the transmission. Then you take the special tool. It's kind of pricey. This tool is about $50. I think you could probably make one. It's 275 thousandths of an inch thick. If you had some bar stock that size, you could take a hacksaw and cut a little slot in it. But what you would do is you start the engine up, warm it up, and with it idling in neutral or in park, take the tool and you put it between the sleeve here and your cable. And what you're doing, you're pulling the cable out with the tool. It's going between the sleeve and the end of the cable, and that's pulling it out just slightly. And take a gauge reading. It should be 33 pounds in neutral or park. Now if you put it in drive, it may bump up just a little bit. It may be 35 pounds, and it needs to be 35 pounds in gear plus or minus 5 pounds, or in park 33 pounds plus or minus 5 pounds. And I'll guarantee you, if you made the adjustment like we did a little bit earlier in the video, just like they do on the assembly line, your gauge reading is going to be 33 pounds plus or minus 5 pounds. If it's not, if it's way off, if it's like 60 pounds or something, there's probably something wrong in the valve body. Something is stuck or out of place. The engineers figured that into the equation so the fellows on the assembly line could make that adjustment and not have to fiddle around with the gauges and tools, and it would be right. Tens of thousands of cars were adjusted that way and did just fine. Now the question comes up, can you adjust it a little bit one way or the other? Is there some wiggle room? And yes, there is to a certain degree, and we'll talk about that now. Now, how much adjustment can we make and why would we make it? Alright, the first thing I would do is, after making that initial adjustment, I would take some kind of scribing tool and make a mark right on the sleeve. That would let me know what my neutral position is. And I think you can safely move this sleeve about 1/8 of an inch that way from that mark, or about 1/8 of an inch that way from the mark. And all that will do is change your shift points slightly. If you road test it after you've made the initial adjustment and you made a road test and it shifted just fine, you don't need to do anything else. But if you want it to shift a little bit earlier and a little bit softer, you could take your sleeve, pop it back off of the throttle body and push that little plastic tab down and move the sleeve in about 1/8 of an inch. Now when you did that, you would come over here and the cable would be slack by about 1/8 of an inch. Road test it that way. If it shifts fine, you're all right. If you had a gauge hooked up after you made that adjustment and you put the tool back in, you should not get a reading of less than 25 pounds. If you're less than 25 pounds after making that push-in adjustment on this sleeve, then you're probably kind of in the twilight zone of having the pressure a little bit too low, and you could have some clutches slip on you and you would have some damage. Now, what if I want to go the other way? I want it to shift a little bit later and a little bit firmer. Then I could take this sleeve and move it in that direction about 1/8 of an inch from that initial mark. And of course, when I'm doing that, I not only am taking the slack out of the cable, I'm actually pulling it out or putting tension on it by about 1/8 of an inch. Now that should make it shift a little bit later and a little bit firmer, and if that does fine, then there's no need to make any more adjustment. Now there is a limit to how far you can go in this direction, and I'll show you that by going back to the transmission. I'll take the throttle and turn it to the wide open position, and with it in the wide open position, I can come back here to the transmission TV linkage and I can pull it up just a little bit, not very much, just a little bit. That's the amount extra that you could tighten up on the cable to raise the pressure. If you went much more than about 1/8 of an inch tighter, obviously this would bottom out here and you wouldn't be able to get full throttle. So about 1/8 of an inch more is about as far as you can go in raising the pressure. This concludes the repair part of this video. I hope it's given you the confidence to take on the challenge of overhauling the Ford AOD transmission. Thank you.